All right, math counts. Here we go. This week we're going to look at a travel stretch. I think this is from the 2018 competition book, but this is kind of a good algebra, systems of equations kind of thing to look at. So we're talking about travel or distance. The relationship between distance, rate, and time is the good old dirt equation. Distance equals rate times time. So you can move around your variables, of course. So if you just want rate by itself, you can take d and divide by t. And so if you want the average speed or rate, it would be the total distance divided by the total time. We just get that by dividing both sides by t. So you can find time, which is distance divided by rate. All right. So the three problems that I want to look at today are different kind of riffs of the same type of thing. So the first one is problems where we're catching up. Like one person leaves and the other person tries to catch up to it. Okay, so subject A is going to travel 40 miles per hour in a direction. And then 2 hours later, subject B is going to travel 60 miles per hour in the same direction. Okay, so sometimes it's nice to make a diagram what's happening. So like the subject A leaves and goes in a direction. And then later, the other subject is going to go and catch up to him. So the distance that they're going to travel is going to be equal to each other in these situations. I don't know what the distance is, so I'll just call it d. And distance equals rate times time. All right, now the rates I do know. Subject A is going 40 miles an hour. And subject B is going 60 miles an hour. The time is what's different. So you can do it a couple different ways here. I'm just going to do it the way I always do it. Subject A, we don't know what their time is, so we'll just call their time t. Now subject B, we also don't know their time, but they don't have the same time. T is how long subject A travels for. Since subject B starts traveling 2 hours later, we know that they're not going to have the same time. They're going to travel 2 hours less. So their total travel time, since they start later, is 2 hours less. So they would be t minus 2. Okay, and then we've got two equations here. We've got d equals 40t. And we've got d equals 60 times t minus 2, so we'd need to distribute that. That would be d equals 60t, and then 60 times negative 2 is negative 120. Okay, so we have two equations here with two variables. We can solve this as a system. They're both equal to d, so you can, using the equal values method, you can just replace or substitute d with 40t. So your equation would end up looking like this: 40t equals 60t minus 120. You subtract 60t from both sides, you get negative 20t equals negative, negative 120. Divide by negative, we get a total of 6. Okay, so we've got 6, and that is the hours that subject A traveled for. Subject B would travel for 4 hours, 6 minus 2. And then you can find the distances. You can just do 6 times 40, and you can say, oh, they both traveled a total of 240 miles. All right, next one. Moving apart. So in this one, they're going to go in opposite directions, but they're going to leave at the same time. All right, so subject A travels west at 40 miles per hour. Subject B travels east at 60 miles an hour. When will they be 250 miles apart? A couple ways that you can do this. You can, obviously, we have 40 here and 60 here again. Their times are the same. They're going to leave at the same time. They're going to stop when they are 250 miles apart. So t is going to be equal for them. So what's different on this one is distance. And there's a couple ways you can do it. The way I prefer to do it is just to indicate that they have two different distances. Distance 1 and distance 2. Since they're going different speeds for the same time, they're not going to travel an equal distance. These two distances are different. But here's what I do know. I know their two distances should add up to 250. So I know that distance 1 plus distance 2 should equal a distance of 250 miles apart. And so here's one of my equations. Distance 1 is 40 times t. Distance 2 is 60 times t. So instead of distance 1, I can plug in 40t. Instead of distance 2, I can plug in 60t. So I get 100t is 250, divide by 100, and I get 2.5. So they're both going to travel for 2.5 hours, and that's when they're going to be 250 miles apart. If you wanted to find out how much each of them traveled, you would do, this person is 40 times 2.5, so what is that? 100. And then 60 times 2.5 would be, 150. So this person traveled for 100 miles, this person traveled for 150 miles. All right, next, when your rate is influenced by some kind of outside force. Now these are going to have the same distance, usually a different time, and they're going to have the same rate, meaning that the rate that they're traveling is going to stay the same, but their rate is going to be affected by an outside force. A lot of times you'll see this as like problems where they're on a river or something and the current of the river is affecting them. Sometimes there'll be an airplane flying and the wind resistance is making the plane go slower in one direction and faster than the other direction or something like that. So again, our times are different on this one. So subject A travels to a city going 4 miles an hour. With the wind it takes 3 hours, but against the wind it takes 4 hours. So we only have one subject in this one, but they're going in two different sections. They're going to go to a city and they're going to come back. So their distance is the same. They're going to go somewhere and then come back, same distance. Their times are not the same. When they go with the wind's pushing them, so it takes less time. They're going against the wind, they're fighting against the wind, so it takes more time. Now, they're going 40 miles an hour each time. But when they're going with the wind is helping them along. When they're going against the wind is slowing them down. So we want to know what the effect is on their speed, what the wind's effect is on their speed. So we have two equations here. You just have to really remember to distribute on this one. So this first one is D equals 3 times 40 is 120 plus 3W. For this one, we get D equals 160 minus 4W. And now since D and D are the same, the distances are the same, we can substitute using the equal values method. And we can write the equation 120 plus 3W equals 160 minus 4W. I would add 4W to both sides. I'd subtract 120 from both sides. And then I'd divide by 7. So 7, that goes in there 5 times with 5 left over. So 5 and 5/7 is the effect that the wind is having on their speed. So it is increasing their speed by 5 and 5/7 here. So they're actually going 45 and 5/7 miles per hour. And then here they're going 44 and 2/7 miles per hour. All right, that's all I got. These are distance problems. Remember, not all the problems are going to be like these three. You can always have problems where you're just looking at one person's distance, rate, and time. For these problems, make sure to look at your units of measurement. A lot of times they'll do like miles per hour, and then they'll tell you how many minutes they traveled for. So if you're using miles per hour, your time needs to be converted into hours so that you can use it in the formula. So watch your units as you're going through, make sure all your units are matching up. These are pretty fun problems to do. All right, good luck. Bye-bye.